Hello, guys. Welcome to yet another exciting episode of Cyber Experiments with Jay. Yeah, at Cyber Experiments, this is a lab where we break tools, learn about tools, and we test tools to uncover how these tools really work. So, in today's experiment, we'll be diving into the world of ICMP packages behavior and Ping Flood. All right. So, ICMP is actually a concept that is foundational to network diagnostics and also a common vector for denial of service attacks. All right. So now let's begin with the basics. What is ICMP? So ICMP, or what we call the Internet Control Message Protocol, is actually a core part of the IP suite. All right. So it is used by devices to send control messages, for example, like error messages or error notifications on unreachable, unreachable destinations or timeouts. Now, the most familiar use of ICMP is what we call the ping command. Now, this ping command, what it does is to send an echo request to a target and wait for an echo reply. Now, this echo request and echo reply, it helps us to check if a network, or sorry, it helps us to check if a device is actually online. Okay, it helps us to measure its latency, and it also helps in troubleshooting connectivity issues. All right, but here is the twist. ICMP isn't just a diagnostic tool. It's not just a diagnostic tool. It can also be weaponized. All right. So an attacker can actually weaponize the ICMP and create what we call a ping flood attack, which is a form of a denial of service attack. Okay. So a ping flood is a type of a denial of service where a target is overwhelmed with ICMP echo requests. Okay. So if the system cannot keep up with the thousands or hundreds of requests that is coming in, it may slow down the system and even drop some packets or even crash a system. Okay. So in this experiment, we will simulate both a normal standard ping and we will also do the ping flood attack. Okay. We use a ping command for a standard behavior. We ping a target. We ping a target to see how it's going to respond. All right. Well, we will watch out for the echo request and the echo reply. Then two, we will use the command hping for aggressive flooding. All right. Then three, we will utilize the tool called Wireshark. So Wireshark is actually a network analyzer tool. So it's going to help us analyze the packets that is coming in into the network. All right. Then we'll make use of the task manager to monitor the system impacts. All right. So those are the four tools we'll be using. We'll be making use of Ping, the hping tree, Wireshark, and the task manager to monitor system impacts. Now, moving further, my lab setup includes one, the Kali Linux machine, which we'll be using as the attacker's machine, and two, a Windows virtual machine, or called the Windows VM, which will now be our target machine, and also where we'll be analyzing the effect or the behavior of the ICMP or the packet that is coming in from our Kali machine. All right. So note that both systems are actually on the same subnet. Okay. So both systems are on the same subnet so that we can keep the traffic internal and in a controlled environment. All right. Now, to begin the experiment, we will start by checking for connectivity between the attacker and the target machine. So we'll be sure that both systems can communicate with each other. Then, secondly, we will use the standard ping command to observe how the Windows machine will react to a normal ping or a standard ping command. Then, three, we will use the hping command, which is the flooding, to also observe how the target machine will behave under a stress or under a flooding. Okay. Then lastly, we will now analyze the behavior using Wireshark to see how our system was responding and what really happened in this whole experiment. So Wireshark will be the end of it. We use Wireshark to analyze what really happened and how our system was able to analyze every packet that came in to the system. Okay. So to begin this experiment, first, let's confirm or let's verify that both systems can communicate with each other. So to do this, let me open my terminal on my Kali machine and let's before we send a standard ping command, let's check for our IP address to make sure that both system or both machines are on the same subnet, all right, or on the same network. Okay. So to do that, I use IPA, and this is my Kali address. So I'm on 192.168.100 or the 100.10. Okay. So let's go to our Windows machine and let's go to search and enter CMD as a command prompt. So once the command okay, now I'll enter the command IP config to check for our IP address, and you can see this is my IP address 192.168.100.11. That means both machines are on the same network, they're on the same subnet, so they can communicate. So I'll send a standard ping command from my Windows to my Kali and from Kali to my Windows. So to do that, I'll do ping 192.168.100.10, and that's my Kali address, and that is it. So I've sent 4 requests, and I should get a reply. All right. So let's head back to our Kali and let's ping our Windows from our Kali on 192.168.100.11. So let's see. And you can see both systems can communicate. So let's stop the communication. All right. So both systems can communicate. But how do we see that they're actually communicating? So that is when we use a tool called Wireshark. So let's open Wireshark and let's observe how this packet is sent. All right. All right. So Wireshark is up and running. So Wireshark is up and running, and we have several network interfaces that we can actually capture our packets from. All right. We have Internet 2, as you can see, we're already seeing data flowing on this network, and on this interface we are seeing that packets are flowing. We have Internet 2 and we have Internet. So let's check which we want to capture network from. All right, so this is our internal address on 192.168.100.11. So we want to capture network on this internet adapter, not the internet adapter 2. We want to capture network from this interface. Okay, so we head back to Wireshark and we select this interface and we click on this blue thing. All right, to start capture. So we are starting to capture. Okay, so let's head back to our Kali machine and let's send a ping command. Let's head back to our Kali and send a ping command. Let's do that now. So this is our Kali machine. So this is our Kali machine. So let's send a standard ping command from our Kali to our Windows machine. So ping 192.168.100.11. That's our address for our Windows machine. So enter. We capture just 2 times. Okay, we are done. So we just sent 2 requests. This is request 1 and this is request 2. So now let's analyze these 2 requests on our Windows machine. So let's head back to our Windows machine, and this is our Windows machine. So what do we have? Now, looking at this interface, we can see that Wireshark was able to capture this packet that came in. Okay, so we have the source to be 192.168. So let's stop the packet, the capture first, right? Let's analyze. So we see 192.168.100.11. This is the Kali machine source. So this is coming from this source IP. This is the source. This is the source IP. So this is our Kali machine. This is our Kali IP, and the destination is our Windows machine. And this is Windows machine, and this is IP. So this is the request that was sent from our Windows, from our Kali, and this is the reply that was sent from our Windows machine. You can see this is the Windows machine. The destination is now the source. So the source is now the Windows machine sending a response or a reply back to our Kali machine. All right. As you can see, this is an echo request with a ping command, and we have an echo reply, which also echo reply ping command from our Windows machine. Okay. Now let's quickly analyze what we have here. So once we select this, let's select this ping request and let's analyze. Okay. So we'll expand this details box, and under it we see this internet control message protocol. This is ICMP. So let's analyze what's happening here. Right. So now checking on it, we can see the type. The type is 8, and that is for echo request. That's a ping for echo request. So we can see that what we received to our machine was an echo request, and you can see the checksum is correct and the status is good. That means we received this request successfully and it was good. And you can see the identifier, and you can see the identifier and the sequence number. All right. So the identifier and the sequence number is actually used to match requests and replies. Now let's look at TTL. That's the time to leave. So the TTL shows how many hops the packet has taken. Okay, so that actually shows how many hops the packet has taken before getting to its destination, right? So if we see a round trip, it indicates latency. The round trip time indicates latency. Packet spacing as a regular intervals between our requests. Okay. That is basically what a standard ping looks like. So we can use this to diagnose if our machine is actually connected, if it's receiving, signal. You understand? If machine can communicate on the network. So with this, we can see that both the Windows machine and the Kali machine can actually communicate with each other. All right. So now let's move on to simulate a ping flood attack. But before we do that, let's reopen Wireshark. Let's close and reopen Wireshark. We need a fresh Wireshark page to do that. We could have just clicked on new capture, but let's close and open. Okay. So we have a fresh page. All right. So why? Okay. And we click on capture. All right. So while Wireshark is opening, let's open another utility tool called the Task Manager. It's a very, very effective tool for diagnosis also. So this is a task manager, and as you can see, our task manager, you can see that our utilization, we're using about 20%, okay, 10%, the 5, so that means our system is in a healthy state, is not overused, we are not overusing the system, we are good, okay? You can see utilization at this low level, you can see nothing is coming in, and the task manager is telling us that our machine is in a good state, is not overwhelmed, and we are good. All right, then you can see in our capture, Wireshark is not capturing any data for now, no packet is coming in. Now let's head on to our Kali machine and simulate a flood attack, or kind of a denial of service attack, which is called a DOS. So let's simulate that. So now let's overwhelm our target machine with lots of ICMP packets. Let's flood our target machine. So to do that, let's enter the command sudo hping 1 for ICMP, and let's specify that we are flooding our target machine at 192.168.10.0.11. Okay, so I will run this command, but I will have to quickly stop. Maybe after 10 seconds, I have to stop so that I don't overwhelm our target machine. Okay, so press enter, and I think so the command is sent. So let's go to our Windows machine and let's observe. So this is the observation. So let's quickly look at our task manager and let's see what's happening in the task manager. As you can see, our task utilization is 60. You can see we're having a lot of requests that is coming in. Right, we're having a lot of requests that is coming in, so our system is using so much resources to stay. But before the attack came, you can see we are on a very low usage. We are on very low usage, less than maybe 5% thereabouts. But since the attack started coming in, you can see that we have gone up to about 60% in utilization. So we are using so much resources of our system, and yeah. So imagine you really dealing with a real attacker. This kind of overwhelming system, and which can cause a denial of service. So let's quickly stop this and analyze. So to do that, I'll just use Ctrl C and stop the attack. Now let's return back to our Windows machine. Let's stop this and let's watch. You can see even after stopping, the packets are still coming in. They are still coming in because a lot of packets is being sent, and I think it has stopped. All right, so let's head back to our task manager. On the task manager, as you can see, the system is cooling down from the ping. You can see the system is cooling, and we are about 13%, and I know that with time we are going to go down, and we are even 5%, 3%, and we are cool. We are back to normal, and as you can see, our Wireshark it has captured everything that actually happened. Yeah. So as you can see, we have lots of the system is trying to reply as many requests as possible. But on a recent, we're supposed to be having a request and a reply, just how we had it in the beginning. Yeah, when we did the request, we said we saw a request and we had a reply. We have a request and we have a reply. But now, as you can see, we have so many requests that is not filled. You can see so many requests. We have a lot of requests that were sent, which the system could not keep up with, and the system is trying its best to reply all of these requests that was coming in to its system. So this is what an Ping Flood is all about. So as you can see, this is an evidence of what an ICMP packet behavior looks like when it's used in a standard way for diagnosis, and when it is weaponized and used as a denial of service attack. If this was in a real industry, in a real industry, this will actually cripple or even stall the workflow in an organization. When the system uses more than 60 to 80% of its resource power, there's possibility that the system might just eventually crash. And you can see we are not sending any requests, and we are low at even 6 to 10%. But if we start sending a flood into the system, we can go as high as 60, 80%. And if we can even proceed higher, we can use up to 95% to about 100%, and that we can eventually crash our machine, and we don't want that to happen. So we are done with this analysis, and yes, we have successfully shown that how ICMP behaves and how the system reacts to echo requests and echo reply. So that wraps up our experiment on ICMP packets behavior and ping flood. So what we've done so far is that we have verified communication observed in a normal ping traffic. We've also simulated in a flood traffic, and we have analyzed the impacts using Wireshark as we did, and even the task manager, which is this. So we have seen what happens, how the system tries to keep up with this request that is coming in, and how it's trying its best to reply the messages that is coming in. Okay, and we saw from our task manager that the system was using more than 60% of its power to work, which is actually not ideal. So yeah, Now, this experiment also shows how simple tools like ping and the hping command can, reveal a lot about network behavior and why monitoring and controls are essential. Okay, so thanks for watching Cyber Experiment with Jay. So until next time, let's keep experimenting, let's keep learning, and keep what building. And don't forget, if you find this piece of information is useful, resourceful to you, please just hit the like button, subscribe, and comment and share your views so we can learn from each other. This is a lab where we test tools, where we learn. We learn by doing. We test things. We uncover tools to grow our knowledge in the industry. Until next time, keep experimenting, keep learning, and keep building. Thank you very much.